we're going to take a look at the last two series tests for this entire section, which are going to be something called a ratio test and a root test. And these are going to be pretty powerful tests. So we're going to be using them a lot in subsequent sections when we start taking a look at why we use infinite series. And so the objective of this section, make sure that we can use the ratio test, make sure we can use the root test, okay, to determine if series converge or diverge. So let's say that we have an infinite series. And if we were to take the ratio of every subsequent term in the sequence, and we divide that by the original term of the sequence, and that equals L, which is some real number, and L is less than 1, then the series is going to converge. Now, if that value is greater than 1, the series is going to diverge. And then if L is going to be exactly equal to 1, then the ratio test is going to be inconclusive. All right, so really, again, just like a lot of other problems, it's just making sure that you can take an infinite limit and be careful with your algebra. All right, so a prime example of when to use the ratio test is going to be on this minus 3 to the nth power divided by n factorial. Anytime you see a factorial, the first thing that should come to mind is you want to try to use the ratio test. All right. One of the easiest way to simplify factorials is to be able to just go to the next term in the sequence. So what I'm going to do is I'm going to set this up and I'm going to have the limit as n approaches infinity of the absolute value. Now remember, we're looking at the next term in the sequence. So this is our sequence, and the next term is going to be minus 3 to the n divided, or n plus 1, excuse me. And we're going to divide that by n plus 1 factorial. Right? So this is our a sub n plus 1. And then a sub n is just the original sequence. So that's going to be minus 3 to the n divided by n factorial. Now, two things we can do to simplify this. Number one, since we're taking the absolute value, this and this can go away, the negative, all right? Because those are going to alternate between negative, positive, negative, positive. So, and the other thing we could do is we can multiply by the reciprocal, all right? So this is going to be 3 to the n plus 1 divided by n plus 1 factorial times n factorial divided by 3 to the n. And that says the limit as n goes to infinity. Now, if we simplify this, okay, that's going to turn into the limit as n approaches infinity. And I'm just going to break off this 3. Okay, so I'm going to rewrite the numerator as 3 times 3 to the n. And the other denominator, I'm just going to leave as 3 to the n. N factorial is n times n minus 1 times n minus 2, all the way down to 3, 2, 1. Okay, so that's our definition of n factorial. And then n plus 1 is going to be n plus 1 times n minus 1 times n minus 2, all the way down to 3, 2, 1. All right, and now we can cancel some things out. So these 3 n's or 3 of the n's are going to cancel. Notice that everything is going to cancel over here. And now we're just left with lim as n approaches infinity of 3 over n plus 1. And we know if we apply n equals infinity, you're going to get 3 over infinity, which is going to be 0. Right? Now, if we go back up to our rules, that's going to be our L. And clearly, L is less than 1. So the series converges by the ratio test. Okay, so our original series, n equals 1 to infinity minus 3 to the n over n factorial converges. All right, now we could have used the alternating series test on this one, okay? But a little bit easier maybe to use the ratio test, all right, especially if you start getting good with the algebra for this, okay? Another example of where we can employ the ratio test, all right? So we have n to the 200th divided by 2 to the n. Okay? Now, this one's a little bit sneakier because if we look at this, we might not know a test to apply to it immediately. So I'm going to go ahead and I'm going to take the limit as n approaches infinity of, now remember, we're plugging in n plus 1. So this is going to be n plus 1 to the 200th divided by 2 to the n plus 1. So that's our a sub n plus 1. And then we're going to divide it by the original series, n to the 200 divided by 2 to the n. All right, and that's going to be our a sub n. All right. Now, next thing we're going to do is we're going to multiply by the reciprocal. Since nothing alternates terms in this, we can get rid of the absolute values. So now we're going to have the limit as n approaches infinity of n plus 1 to the 200th divided by 2 to the n plus 1. And then we're going to multiply that by the reciprocal of the denominator because we're dividing. So that's 2 to the n divided by n to the 200. All right, now, what I like to do is I like to group like-looking factors. And so I'm going to rewrite this as lim as n approaches infinity of 2 to the n over 2 to the n plus 1. And then I'm going to multiply that by n plus 1 over 200 divided by n to the 200th power. All right, so what does that mean? Well, we can simplify both of these. So now we're going to get the limit as n approaches infinity of 2 to the n divided by 2 times 2 to the n. So we just break off this 1, just like we did in the previous problem. And then what we can also do is we can group these because they both have a 200 power. So we can rewrite this as n plus 1 over n to the 200th. Right? Now we know that this is going to cancel out and we're left with a half. So we're left with lim as n approaches infinity of 1/2. And then we can break this up into two smaller terms because we have monomial. All right, so that's going to be n over n plus 1 over n to the 200th, or lim as n approaches infinity of 1/2 times 1 plus 1 over n to the 200th power. And our limit laws say that we can just go ahead and make that go to 0. All right, so we really just get 1/2 times 1 to the 200th, which is 1/2, which is equal to L. And clearly, 1/2 is less than 1. Okay, so we go back up to our rules. And remember, our rules say that if you take the ratio and you take the limit as n approaches infinity and it's less than 1, then the original series converges. So this series is going to be convergent. Okay, so hence our series n equals 1 to infinity of n to the 200 divided by 2 to the n converges, okay, by our ratio test. Okay, so we're going to take a look at a couple more difficult ratio problems in the next videos, but hopefully this gives you an overview as to how to go about implementing the ratio test.